Welcome to this lecture for Research Methods, Dr. Sam Fiala. This time we're talking about developing a research hypothesis, coming up with an idea, and then getting that idea to the hypothesis stage. So, overview, we'll talk about different approaches to generating a research idea, some advice on finding source materials in terms of cultivating that idea, and then the process of moving from idea to hypothesis. Okay, talk about 4 general approaches to idea generation. A theory-based deductive reasoning, observation-based inductive reasoning, addressing real-world problems, so applied behavioral science, or probably the lowest hanging fruit, the easiest method, starting off by finding an interesting empirical article and using that as a springboard. Okay, so the first one, using theories. So starting off with, well, what are good theories to use as a source of a research idea? Well, good theories are generally, they're general, they're parsimonious, falsifiable, and they allow for making predictions. So when we say a theory is general, it means that a theory can summarize many different outcomes. Not necessarily all outcomes, but they're not super specific, right? So if you have a theory about helping behavior, about why people help in some situations versus others, it's not, oh, well, this only applies to helping in office settings. Well, that's kind of limited, right? So we want something that's broader than that, but it may not cover every helping situation, right? So you have, oh, your theory about helping behavior. Will it tell you what's going to happen if the person in need of help is maybe evil? Like if Hitler's drowning, how do you know if somebody's going to help them or not? Okay, maybe your theory doesn't cover that eventuality. So they're not exhaustive, but they're not super focused, super specific. They're fairly broad, right? A good theory is big, right? And one thing that makes it good in terms of being a source of research ideas is it gives you more ground, more places where you can now focus on something specific within that larger umbrella. Good theories are also parsimonious, right? So a good theory provides the simplest explanation for some set of outcomes. And again, simple is good, but it's not as, oh, if there's 2 theories, the simpler one's always better. It's if 2 theories explain something equally well, so they explain the same amount, they're both predict something equally well, but one's simpler than the other, then you go with the simpler one, right? That's one of the values of science. A good theory is also falsifiable, and really that means 2 things. One, the variables of interest in the theory specifies, the constructs, are measurable, right? So they're things that can be observed or measured. So if you have a theory about, your aura or your chi, okay, that may have some truth to it, but it's not a scientific theory, right? Because scientific theories have to be about things that are measurable. And then to be falsifiable, the things have to be measurable, and then predicted relationships among variables or constructs, it must be possible that they can be shown to be incorrect through research. Right? So if you have, oh, I've got this theory that there are magnetic fields around people that they can be manipulated to change their mood, and that's how I do therapy. And say, okay, we set up a test, and okay, so manipulate these people's fields and not those, and let's see if their mood's different. And we find the mood's not different, and the person who can do this manipulation says, well, yeah, there must have been a shift in the Earth's magnetic field during the test, or maybe it was sunspots, or it could be that your lack of belief generates a counterproductive magnetic field. Okay, well, if they can't be proven wrong, so like no matter what the outcome is, if the theory can kind of twist and turn and say, yeah, but that fits in the theory too, that's not a good theory. It has to be where the predictions can be falsifiable, where it can be proven to be wrong over time. Right? And obviously, a good theory, a useful theory, is one that allows for making predictions, right? Where we can draw down via deductive reasoning. If this theory is true, then this is what we should see, right? So if Bowlby's attachment theory is true, that these early life experiences contribute to these internal working models for individuals based on relationships with primary caregivers that will then shape the way they see themselves, the world, and others, then we should see differences in people as adults in terms of how they see themselves depending on what type of relationships they had when they were young. So children that were brought up in an orphanage who are cared for by possibly loving caretakers, but people that aren't able to give the same amount of caregiving as a primary caregiver. So these people in an orphanage should look different than people who grew up in their own home with primary caregivers in terms of how they see themselves as adults, right? That's a prediction that can be drawn down from attachment theory, right? So if the theory is true, then, well, this is what we should see in some context, some setting, right? One way to use this to develop a research idea and a hypothesis is to challenge the status quo. So if there's some theory that says, okay, here's what should happen, and you think, yeah, but what about this, right? I don't think that's true, right? So if you kind of go into this reading different theories about behavior, about psychology, and you go into this kind of skeptical mind, like, yeah, I don't think that's true. What about this? What's the counter explanation? That can be a good springboard into research ideas. Similar to that, look for exceptions to the rules. Okay, yeah, maybe that's generally true, but what about for this type of people? What if this thing is happening? What if there's this cultural difference, this age difference? What if there's this difference in time, right? So what are the exceptions to some theory, right? Are there any exceptions? And that can be something that can be tested, right? That can lead to a hypothesis. Sometimes you'll see that there are different theories that will lead to opposing predictions, right? Well, this theory says that this should happen. Oh, this theory says the opposite should happen. That's a great way to come up with research ideas, because then you're pitting one theory against the other, and we're going to move science forward because there's going to be a winner and a loser. One's going to get more support, and one's going to have support eroded. And that's what we need to do. We need to be pushing the good theories up and then pulling the less effective theories down and winnowing away the chaff, as it were, right, till we get closer to this truth that we're all seeking in science. And again, putting two things into the arena at once is kind of an efficient way to move towards that truth that we're working toward. Another thing, just kind of mechanically, that I think is helpful is trying to visualize relationships among constructs that a theory specifies. And by this I mean, get on a whiteboard, a chalkboard, and start writing down, okay, well, here's this this construct and this construct, and there's this kind of causal arrow that goes left to right. And okay, well, is there something else that comes in and affects that first variable? Or does that second variable then have some outcome that it affects? Or is there some intervening variable where the relationship between these two things will depend on some other thing, right? And you start drawing these things on the board, you can sometimes visually get a kind of a revelation, an idea will pop in your mind. Oh, how about this? Has anybody thought of looking at it this way? For those of you particularly who are visual thinkers, that may be the way to go rather than just reading through articles and hoping for some inspiration. But again, using theories is one of the best ways to come up with research ideas because, again, we want to push the good theories forward and pull the bad theories away to collectively move the field forward, right? If we have studies that have no tether to a theory, well, that can be problematic because we don't know what to do with them and we're not moving anything forward. We just find, oh, this is interesting. What does it mean? I don't know. There's no context for it. However, there is kind of a different approach. So instead of going from theory down to hypothesis, you could go the other way, using observation. So using inductive reasoning, right, where you're observing patterns based on your experiences or things you've read, things you've seen, things you've heard, and go, I wonder, based on what I'm seeing, if this is related to this. So basically, you're creating a theory from the ground up, rather than coming from, okay, here's this theory, I'm going to draw down from it, right? So you're going to inductively reason up to a theory and to create a hypothesis. And obviously there's going to be some reliance on intuition here, right? There's some, and it's one of the things that's exciting about this approach is there's some creativity involved, and there's opportunities for some unique innovations in the field, right? Where you're not just going with these kind of old ideas, but hey, maybe there's a new idea. People have been thinking about it all wrong, and here's this new thing I'm going to discover. But as we talked about before, there are some limitations to intuition, right? We have our cognitive biases that make it problematic in some instances. And obviously, this is something that's easier for those with lots of experience. So whenever we look at kind of the large figures in the history of psychology and behavioral science that came up with theories that moved our knowledge forward, that did so via inductive reasoning. Arguably Freud did to some extent, Piaget certainly. They had lots and lots of clinical experience, different types of clinical experience for those two examples, before they got to their theories. They didn't just go to the park and look around and go, you know what I think about people? No, they were working in their fields. Piaget observing his own children systematically, methodically, to come up with his stage theory of cognition. As I said, there are some limitations to the inductive approach. May not advance the field, right? Because if you're going from the ground up, having some whole new theory that doesn't relate to anything else, we don't know where to put that. That doesn't push anybody forward, doesn't pull anybody back. It's just, okay, here's this other thing now we have to worry about. Which again, maybe it's fantastic innovation, or maybe it's just this quirky thing that has no relevance. Right? And because of that, I think there's kind of a bias in the field that studies like this may be discounted if there's no connection to existing knowledge, right? Because if they don't know what to do with it, well, okay, that's cool, but I don't have time to waste cognitive energy on it because it may be a fluke, right? So if you're going to do this, and I think you can, inductive up to some theory, still find some way to relate that theory to other existing theories, right? So would the predictions of the theory you're coming up with be different than some other theory's predictions, right? And now you're getting that testing competing theories, some existing one and your new one, and now you're moving in the field forward, potentially. 3, addressing real world problems. So testing possible solutions to problems. So, we see these kids engaging in violence at what seems like an increasing rate, at least in terms of more use of lethal force in children in schools with shootings and whatnot. What can we do about it? Okay, well, let's try to figure out what's worked before, what hasn't worked, and maybe we can come up with maybe if we do this, that will decrease the likelihood. Right? And then you can go do research to see if your solution works. Right? Before you do that, typically a preemptive step is identifying kind of risk and protective factors. Right? So before you go, hey, will this work? You need to know, well, what are the things that make it more likely that people are going to be aggressive? What are things that make it less likely that they're going to be aggressive? Right? So you start with more of a correlational design first, until we find out what the variables are that predict it. Okay, so kids that, just making something up now, they eat lots of oranges, they're super violent. Okay, there's this correlation between orange eating and violence. Is it a causal relationship? I don't know. So now we'll do an experiment, give lots of kids oranges, and see if they're more violent. But we don't know to do that experiment until we've done this kind of more basic correlational studies to see what are the things that make the problem more of a problem, what are the things that seem to be related to less of a problem. Right? And so exploring risk and protective factors is a great way to approach real world problems. Again, not looking at the solution just yet, but trying to identify potential solutions, right? Or at least identify, well, what is causing the problem? But again, because you're doing correlation research, you're not identifying the cause, you're identifying potential causes. Right? Another way just to kind of think about this in terms of shifting your focus from kind of a positive psych perspective, not just looking for what are the problems, well, what are the successes? What things are going well, and then trying to figure out why they're going well. So look for the predictors of successes, and then again you can from that, if there's research out there, okay, these variables are predictive of success. Okay, can we then have an intervention that is based on those predictors? Okay, if kids that have this, and this are more successful, okay, so if we now design this school that do have this, and this, will they be more successful now that we're doing it intentionally? So you're going from correlational to experimental, but instead of looking to just fix a problem, you're looking to find something that seems to be working and say, okay, can it work in a cause and effect type of situation? The fourth one, and this is probably the one that most of you will find the easiest to do is start with an interesting article. So just, start a literature search, some topic you're interested in, until you come across some article like, that's an interesting study. I like how they did that. I like the way they have that question. So the lowest hanging fruit, the easiest thing to do, if you find an article that's really interesting to you, man, I wish I'd have done that study. At the end of pretty much every empirical article that's published, is the last paragraph in the article. The sentence will begin, future research should, and then they'll make recommendations at the end of the article about what future studies should do. And this is a great place for, particularly in this class, people to come up with ideas for research proposals. In kind of real life, in the world of academia, it's not necessarily the easiest place to find ideas, because it takes a while to get things published. So when those authors wrote that, and they said this is the next step in the study, and they submit it to publication, it may take them a year to get that published. By the time it's gotten published and you've read it, they've probably already started the study that they said should be next. So they're going to beat you to the punch and get published first. But that's fine for this proposal, because you're not probably worried about publishing. So that's a good place to get ideas for future, from that kind of future research paragraph. Another thing is to think about what were the limiting conditions of this article or other research you've read. So what are the limitations? What things maybe could have been done better, and things that maybe limited either the internal validity of the study. So the internal validity is the degree to which the cause and effect relationship, we can be confident that it's true, right? So, oh yeah, they maybe had a confound, or something was a little wonky. I'd run that study again, but I'd fix it to where it was clear that A caused B, right? Sometimes you'll find that. More often, what you'll find is opportunities to address limitations in terms of external validity. External validity being where it seems like the finding in the study is true, that it's done well, where, yeah, in this study, for these people in this sample at this time, there's a true relationship. But the question is, okay, how true is it for people that are slightly different from the people in that sample? If people took slightly different measures, if the experimenters involved did things a little bit differently, would this relationship, would this effect still happen, right? So how true is this finding beyond the study? External to the study, does that truth generalize, right? So things you might look at are the sample that they use in this kind of article you find interesting, the size. If it was a fairly small sample, okay, they only had 25 people, and maybe they didn't find what they were looking for. They said, oh, we didn't find this relationship. However, this may be due to insufficient power because we only had 25 people. Okay, well, you could propose a similar study where you then increase the power. I would recruit 500 participants, right? The composition of the sample, right? So we found this effect for single mothers in Finland. Okay, that's cool. What about single mothers in Queens, New York? Would that same effect be observed here? Or are there some sort of cultural differences between moms in Finland, moms in Queens, that would cause that thing to look different, right? The validity of the variables measured and manipulated, right? So the types of, if they gave surveys or they did observations, how did they do it, and would you do it differently? You know, if they're looking at some study of the effects of playing violent video games, and the video games they used are all first-person shooters. Like, okay, what with first-person shooters, maybe they would have found that. But what if it was a cooperative violent video game? Maybe it'd be a different outcome, right? So think about how you could tweak an existing study, do it slightly differently, and would the outcome be different than what they found? Right? Or maybe there's some extraneous variables they didn't account for, right? So they found, okay, A was related to B, and you think, yeah, but that might be because of C. There's this third variable that could account for that relationship, right? Just like we talked about with the reason you can't infer causation from correlation, these third variables, these outside variables that are maybe related to both of the variables you're looking at. Maybe something like that would occur to you. Another thing you might think of, if you find an interesting article that's kind of in more of the basic research realm, you might try to think, okay, well, what's the applied extension of this effect, this finding, right? So they found this thing about human behavior that's very kind of basic and isn't readily applicable to an intervention. But if that finding is true, then okay, maybe doing this thing differently in therapy and schools and business would be beneficial, would have an effect, right? So you go from basic to applied, or vice versa, where you read an applied article they found this thing that's really interesting, that they change the way people think or do things, and as you're reading it, you think, okay, this applied article is based on, usually most published articles that are applied, they're going to cite some basic research and some core theory, and maybe their finding didn't fully align with the base theory and the kind of the basic science it was based on. Like what they found wasn't fully consistent with what you would have predicted from the basic science predictions. So then you might think, okay, since they found this other thing that wasn't fully consistent, let's go back and do some more basic science and move some things around and see if our understanding of how things work maybe could be improved. Maybe there's some other variable, some moderating variable going on here. Another thing to do would be to look at who cited that article. Again, you found some article you're super excited about. Typically, especially if you're using PsycInfo, a database, there's on the citation, there's a little thing that says, cited 10 times, cited 100 times. If you click on that, it'll take you to the references for all people who cited that article. And also you can see, if you get the article, look at the references, see who they cited, right? Read those articles, both who cited them and who they cited, and see, is there any area of disagreement, right? Well, okay, the article you were interested in, they said, this is what it means, and somebody else had a different interpretation of the phenomenon of study, and then now you've got some competing ideas. Okay, maybe you can come up with a study that will pit the two explanations against each other. Again, more likely to move the field forward if you can do that. It's most efficient when you have kind of competing ideas. Excuse me. Okay, so looking for those areas of disagreement. Okay, so where do you find this source material? Where do you find these interesting articles? Well, first of all, let's talk about the different types of sources. One way to think about it are primary sources and secondary sources. Primary sources are those where the authors are reporting on what they found, right? We conducted research, we gathered data, we analyzed it, here's what we found. We did this. Here's our work. Here's my painting hanging in the gallery. I did this. That's a primary source. Right? Secondary sources are those when someone's reporting on what someone else found. And usually secondary sources are combining a bunch of findings from a bunch of other primary sources, and then typically relating them to some theory, right? So articles you'll see in journals, in peer-reviewed empirical journals, are typically going to be primary sources, and book chapters, more likely to be secondary sources. Now, not every article in a journal is a primary source, right? Because there are frequently in journals review articles where somebody's just reviewing here's the current state of the field, here's what we know about this topic, right? So they didn't conduct any studies themselves, they're just reporting what everybody else found and trying to put it into some context about how the state of knowledge has changed over time and then point in future directions. Again, both of these are good sources of information, but they do different things for you. Both will be useful at the start. I'd say secondary sources may be even more useful because they tend to be more broad and more general. But ultimately, when you get to writing your paper, you're probably going to be citing 2 or 3 secondary sources, and then the rest will be primary sources. You should be primarily citing research. Jones and Smith conducted a study of these people and found this, right? Reporting what these people found, not reporting that so-and-so said so-and-so found, right? You don't want those secondary sources. You want, what do people actually find, rather than somebody else's interpretation of it. I want your interpretation of what those people found, where basically you're becoming the secondary source. Another differentiation are scholarly sources versus popular media. Scholarly sources are ones that you're going to find via the library databases. I again recommend PsycInfo as your primary one. Peer-reviewed, right, where before something gets published, it gets sent out to people in the field that review it, make comments, and then it goes to the editor, and then the editor decides if you have to then make revisions or not, and then if it gets published or not. So not just everything gets put out there. It's a selective process, and things get screened. So you should rely primarily on scholarly sources. I think it's okay to start with some popular media stuff. I'd include in that Wikipedia. I don't see as a scholarly source. It's more popular media. But it's not a bad place to start, especially if the topic you're interested in is something you're not super familiar with and you're just not sure what the terms are, how do they refer to these constructs, what words are used. Well, start with Wikipedia because they're probably going to use the words that you need to use when going back to a database as search terms. So you can get kind of this broad overview in popular media, but then most of your searching should ultimately be among scholarly sources. The exception being, sometimes in the first part of a paper, if you want to, establish the importance of some topic and talk about, okay, there's been a perceived increase in racism, sexism, ageism, whatever, you're probably going to be citing some popular media source for that, right? And that's fine. But pretty soon in the paper, you need to get down to scholarly sources, right? Okay, in terms of where you find these things, again, databases like PsycInfo that have search fields. Highly recommend checking out the university's LibGuide. There's a psychology and counseling department LibGuide that links to databases, has a couple of little slideshows on how to find articles that are pretty good. In general, when searching these databases, you want to start broad and then go narrow, right? And so, but sometimes it's overwhelming. I'm kind of interested in autism. So you type in autism, and it comes back with 400,000 articles. Obviously, you're not going to read through all of those, but you can read through the first couple and start getting an idea of, okay, well, what about autism am I interested in? The other thing that may be helpful is when you're searching and wanting to go broad, but not overly broad, is whatever topic you're interested in. So let's say it's crisis intervention for natural disasters. So you put in crisis intervention on one line, natural disasters on another, and then on another line, put in either review or meta-analysis into a search field, right? Because that'll then pull for those articles that are reviews of other research, and those are good things to read first to kind of get an idea. Okay, where are we at in the field? What have people looked at before? What are they looking at recently? What's the suggested future direction of research in this field generally? These are great to start with, but they can be really problematic for you in this paper if you lean too heavily on them throughout the process, because they're not primary sources, right? And so if you try to cite them, you'll be having to do a lot of secondary citations where you say, Jones and Smith found blah, blah, as cited in, and then the article you actually read, because you didn't read Jones and Smith, you read this review article. And that's not the best way to report research. You do it sometimes if you can't find the primary article, but generally you want to go back and find that primary article, because the reviewers may have misstated what the research actually said. You don't want to rely on them. You want to read it yourself. If you're going to cite a review article, typically you want to cite their comments on the state of the field, right? So-and-so conducted a review of the literature and concluded that blah, blah, blah. Okay, that may be helpful, right? If they've kind of analyzed a lot of studies, particularly if it's a meta-analysis where they have applied some statistical analysis to effect sizes of other studies, those can be good to cite. But again, good to start with. Ultimately, get back in the lane of primary sources pretty quickly. As you're going through searching for things, you want to be reading abstracts, right? Looking for, okay, how close is this to what I'm interested in? And when you see abstracts that are interesting, you want to attend to a couple of things. Obviously, the content of the abstract, but also the keywords, the descriptors that are used, which are usually kind of below the text of the abstract, because that'll help you identify what keywords you can use to find articles similar to that one. Also, look at the author's names. Frequently in academia, people publish in kind of a line of research. So, if you find you're really interested in couples interventions for PTSD, and you find somebody that wrote on that, go back and search their name, you'll probably find 7 other articles they wrote about that same topic, right? There's some tips too in terms of using the search fields. You want to combine search terms using these linkages, this and this or this but not this, right? So if you do a search and it comes with lots of hits, but you see, okay, wow, I typed in this thing and it's bringing up all these weird business stuff about HR, and you notice all these HR articles have the word employment somewhere in the abstract. Okay, well then just do what you started with and then add not employment, and that'll screen out every abstract that has the word employment in it because it's not relevant to you, right? So you need to be a little creative. Think logically about the linkages between the terms you're using. If, especially in the early stages, let's say you're interested in something related to the military. So in one of your search lines, so depression in the military. So one search line may have depression. The next search line, you may want to put military or veteran or soldier or army or, so, and all those things with or can be on the same line. Just put each phrase in parentheses, whatever your phrase is, or parentheses, next thing, and it'll search all of those, right? Because you never know what kind of terminology people are going to use. They may not use the same word you use. So think of synonyms is often helpful at the beginning to get that kind of broad net to pull in as many things as possible. Okay, so once you've come up with an idea, either again from deductive reasoning, inductive reasoning, kind of an applied approach, or again finding some article and then moving through that article to find an idea, to get to hypothesis is your next step. So hypothesis being, of course, a testable prediction about a relationship between variables. So what makes a good hypothesis? Well, good hypotheses are testable, right? Kind of like a good theory, it has to be falsifiable. Same idea here. They need to be testable, which means the terminology used, you have operational definitions, and they're specific, right? You don't say, couples that talk more will do better. Do better? What do you mean do better? And when you say talk more than others, or talk more than they used to, what do you mean? Get specific about your prediction, because it needs to be something that can be tested. If it's too vague, then you can't test it, right? And also ultimately may not be falsifiable. So you have good operational definitions of your variables. They're specific. Hypotheses need to be positive. Now this is a tricky one for a lot of people, and it has to do with inferential statistics. You can't propose that two things are not related, or that something will not have an effect, right? And that has to do with the way we set up hypothesis testing using inferential statistics. If you want to use Bayesian statistics, probably need another stats class, but you might be able to do it. But the way that we traditionally do things, you have to propose that you will find a relationship, that you will find an effect. And if you're interested in, you think, people say that this causes this, but I don't think it does. Okay, the way to sneak that in is have another variable. So they say that A causes B. I don't think it does. So I'm going to look at A and C as potential causes of B and predict that B will cause, or C will cause B, but A won't. Okay, now you can do that because you've got some positive aspect in there. But you can't just go in and say, yeah, I think nothing will happen. Because it's too easy to show that nothing will happen. All you got to do is do a bad study, get a sample size of 2, randomly assign one person to the control group, one to the experimental group. Hey, guess what? I didn't find a difference. Told you, there's no effect. No, you had no power, right? It's really easy not to find something. And because of that, we can't propose that we're going to not find something. You have to be looking for something, for some correlation, for some effect, for some difference. Now this one is in bold for a bold reason, right? Particularly for your proposal, your hypothesis needs to be supported and supportable by a theoretical or empirical rationale, right? So here's what I think is going to happen. And if I ask you, well, why do you think it's going to happen? You can't just say, I got a gut feeling. I think this is good. Intuition is not sufficient for his proposal. You have to be able to defend why you think this is going to happen. Either, oh, because of this theory, I've deduced this, or because somebody found this, and they found this, and they found this. You put those three ideas together, it's clear that my idea will be correct, right? So it has to have some support, theoretical, empirical, or both. And then, of course, the hypothesis should be relevant, right? It should add to knowledge of the human condition in a meaningful way, right? And not all studies are equally relevant, but we try to stay away from really trivial questions that are unlikely to have an impact on humanity, right? So, you've got some research question about, which color of Frisbee do college students prefer? Well, I really think it's going to be green, and here's why. Who cares? It's not a really meaningful question, right? Unless you own a Frisbee company. So something that's relevant, that's meaningful. It doesn't have to be earth-shaking, earth-shattering, change the world, but it should have some impact, potential impact on our knowledge of human behavior that has some meaning, some relevance. If your hypothesis is about a cause and effect relationship, then you're going to use an experimental design, right? And in that case, you're going to be specifying an expected relationship between an independent variable and a dependent variable, right? That it's expected that depending on the level of the independent variable, depending on what level of drug they get, how much TV they watch, whatever it is you're going to do to them, that this dependent variable, scores on this dependent variable will be different depending on what I do to you on the independent variable, right? If you're not ready for a kind of a causal prediction, you think, I think these things are related, you're probably going to use a correlational design. And in that case, you're going to have a predictor variable and either outcome or criterion variable. Outcome and criterion can be used interchangeably, mean the same thing. But we try to stay away from using independent, dependent for correlational studies because it confuses people and they start to assume, oh, independent variable must be causative. Again, save that language for experimental designs. Okay, take home, wrapping up. There are obviously multiple ways to develop a research idea and hypothesis. We've talked about a couple of them. When you're doing this work, one of the key things is your hypothesis for your proposal should be relatable to existing theory or findings, right? You can have something creative and cool, awesome, super exciting, should be something you're interested in because you're going to spend a lot of time on this project. But it's got to have some tether, got to have some tie to the existing literature, either theory or findings. And it can be that the tie is my predictions are complete opposite of what everybody else says. That's fine, as long as it's in relation to. Either they're opposite or they're consistent with, and I'm just extending it for this other population, this other way of doing things. That's fine too. But make sure your hypothesis is defensible. You've got reasons why you expect the outcome you expect, other than just, I got a feeling. Revelation of a revolutionary idea is unlikely. So don't put too much pressure on yourself to, okay, I got to come up with something that nobody's ever done before, that's going to change the world, and it's going to be the best thing ever. Probably not going to do that. Right? You might. I'll be super excited if you do. It's unlikely. Those things, those ideas come along rarely. But that's okay. They don't necessarily need to. Science, behavioral science in particular, builds slowly. It doesn't take these huge leaps where, okay, we kind of know this, and then, hey, guess what? We know this whole new thing now. No, we kind of know this, and we're refining our understanding of human behavior. Again, giving more support to some theories, taking away support from others as we slowly move forward via this kind of processes of replication, extension, failure to replicate, refining theories, refining ideas. It's very workmanlike, and that's okay. So don't worry if you feel like I don't feel like I'm taking a big swing here. That's okay. Little swings are good, especially if you can articulate your idea well. It's defensible, it's relatable to existing theory and research. Then you're gonna do well. Okay, that's all for now. Take care.